Okay, see, two parallel plates are separated by, these are horizontal ones, 15 centimeters. So our delta R is 0.15 meters, right? We've got a little chunk of stuff in here, 0.19 grams, right? And there's 230 volts. The top, 213 volts, right? The top plate is positive, bottom plate is negative. So by the way, this thing has to be a negative charge because gravity is going to be down, right? mg is going to be down. So if EQ is up, if we're exerting an upward force, it must be that the top is positive. If the top is positive, this must be a negative thing to be attracted to the top, okay? So this thing must be a negative charge in there. Okay, so now the question is, what's the charge on the styrofoam? Okay, so what we're going to do here is we're going to say that the force up, which is EQ, is equal to the force down, which is just mg, right? So gravity equals this, right? The electric field is going to be our change in voltage over R. And I'm ignoring the minus sign here because we already figured out which direction everything is, right? Okay. And now we're set. Now we can just plug in numbers, right? We know it's 213 volts that changes over 0.15 meters. Q is what we don't know. Our mass is 0.190 times 10 to the minus 3rd. Because notice I give it to you as grams, right? But we got to use kilograms. Okay, and then our G is 9.81 newtons per kilogram on Earth. And now we're set. So I'm going to go 0.19 E minus 3 times 9.81 times 0.15 divided by 213. And I'm getting that Q is 1.31 times 10 to the minus 6 coulombs in magnitude, right? And then we decided that it had to be a negative charge because if the top plate's positive and the bottom's negative, the only way to exert an upward force on a charge is if it's negative. That is, it's repelled by the negative on the bottom, attracted to the positive on the top. So Q is negative 1.31 microcoulombs. Ta-da.